Hello. My name is Jordan Santell from Google Daydream WebXR team, and I'm excited to share with you our explorations in augmented reality on the web. Our team is very much like a R&D type team, and where we're exploring how AR and VR will act on the web in the future. So what is augmented reality? If you've used Pokemon Go, Snapchat filters, you already know what augmented reality is. But more formally, AR is the compositing of the digital world on top of the real world. AR is very similar to VR in terms of this immersive spectrum. So if you take AR and completely, everything is in the virtual world, all opaque, then that becomes VR. So immersive computing is technology that operates on human immersion. When that's on the web, we call it the immersive web. So we've been dreaming a lot about the future of the immersive web 5 to 10 years from now. And I'm excited to share with you the story of our foundational block of work for this, bringing augmented reality to the web. And I'll also talk a little bit about what's coming up next in the near future, what could be going on in 10 years from now, as well as the challenges it brings and why this is an exciting time to be jumping on this new medium. So last summer, Apple released ARKit, Google released ARCore, and these are augmented reality SDKs for iOS and Android devices. This enabled mobile developers to easily create augmented reality applications and provides real-world understanding so developers can create content in order to interact with that real world. So developers having easy access is only one half of the equation. The other half is, do users actually have access to AR-capable devices? Previously, this was limited to dedicated headsets, expensive dedicated headsets, and less stable platforms. But these new SDKs, ARCore and ARKit, only require sensors like gyroscope, accelerometer, RGB camera, things that you can find on most modern smartphones. So no specialized hardware is needed. So right now there's around 600 million ARCore and ARKit devices, so they're out there, users can use them. So it's the perfect time to start bringing augmented reality to the web. And there's like 200 megabytes of animated GIFs here, so it might be a little slow, some of these. So we built some prototype browsers, WebAR on ARKit and WebAR on ARCore. Great names. And these are hacky web views that we use to expose features from ARKit, ARCore to web content. So first we had to identify requirements of which features we need in order to expose, to create these experiences. So we identified 3 high-level requirements that we would need to bring to the web. So first off, we need to know where the device is in 3D space, its position and orientation in order to sync our virtual world on top of the real world. So VR has similar needs. We also have to track the pose there. And so we were able to leverage a lot of the WebVR API here. So sometimes this is referred to as 6DoF, or 6 degrees of freedom. And that's referring to tracking 3 axes of position and 3 axes of orientation. We also need to expose the camera stream and intrinsics. Intrinsics in this case are things like the field of view and perspective of a camera. Again, in order to sync our virtual world with the real world. Mobile platforms only allow one process to access the camera at a time. So since our AR platform is using the camera, we can't also get user media, for example. So we have to have another way to expose this information. And finally, we need to be able to understand the world around us in order to interact with the real world. So scene understanding is this broad description, the catch-all term, for the ability to interpret the real world. So for example, finding surfaces to place an object on it, or estimating light in an environment. So you can see the brave lion up there get scared when the lights go out. So these 3 components are our MVP feature set. And we also, of course, had some goals for this experiment. First off, general API exploration. We wanted to look into the ergonomics or feasibility of different features that we do expose. So for example, earlier prototypes used Tango smartphones, And these were smartphones with infrared depth cameras on them, similar to something like a Kinect. So this gave us around 30,000 3D points per frame to position in the real world and use that in our experiments. So needless to say, pushing 30,000 3D points from the platform to web content, and sometimes in this case to the GPU, was non-ideal. So we learned our initial API for point clouds was difficult to use in a performant way. We also wanted to discover what's possible, what kind of things we can make. So with pose tracking and the camera feed, we can do things like build portals. And since it's the web, we were also able to use physics libraries and surface detection to make an AR mic drop. And we've also had to build tools as we're developing these experiences to debug what we're doing. It was very difficult before we had these tools to do things like visualize the surfaces, so we know if, like, are we finding a plane? Are we missing? What's going on here? Did I break something? And we also wanted to get developers excited about these features. We wanted developers to bug browser vendors, say, hey, we want this, please implement this, and to convince our organizations to check it out. Maybe this is something we can use. And we also wanted to see what cool ideas people came up with. So concurrently, while working on these prototypes, folks from a handful of browser vendors that you see up there were working on WebVR 2.0. Later, this was renamed to WebXR in order to support both augmented reality and virtual reality experiences. So after a year or so, there's now an implementation of WebXR inside of Chrome Canary, I think the latest one, behind a flag. And all vendors that currently support WebVR, all these ones, have all pledged to support the WebXR spec as well. After about 9 months of prototyping and working on standards, we now have a working version in a real browser. So, kind of, asterisk. So when I wrote this proposal for JSConf EU months ago, I was I had no idea what state this would be in by now, but I got pretty close. It's about like 2 weeks away. We're going through the review process right now, and who knew that shipping code to like billion plus users was difficult? So it will be behind multiple flags, and the API will change for sure between several versions. It's very in flux. So now that we have these features enabled in a real browser, we were able to show this off at Google I/O a few weeks back. And so we have this educational site showcasing a statue from Mexico, and it's kind of like this, kind of like a Wikipedia type article with a model on there. And we wanted to show off the progressive enhancement concept, something very webby. So if you're viewing this on a desktop or mobile browser, you can move the statue around with a mouse and keyboard, similar to other kind of 3D WebGL content model viewers. But when you're viewing this on a browser that supports AR features with WebXR, you can also place it in the world around you. I swear the performance is better than this GIF looks. So you were able to place this life-size statue in the real world around you, and these annotations you can interact with. Click on them, and then since this is just the web, you can render these annotations with just HTML and CSS, all the same web tools you're used to. So when we were showing this off in the web booth, there was a web booth and an Android booth at Google I/O, and we were at the Android booth, or I was at the Android booth. So we had a lot of Android developers kind of check it out, and their reaction was they didn't quite believe this was the web. So it was a lot of great feedback and confirmation that yes, the web can performantly run WebGL experiences with AR. So I mentioned earlier scene understanding. So the initial implementation of augmented reality in Chrome only implements one form of scene understanding, a hit test. So this allows you to cast a ray out from your device and intersect with the real world somewhere, some surface, some collision. And this returns a 3D point if found. So commonly in AR applications, you have some sort of reticle that traces real-world surfaces and displays an indicator to the user, indicating there's a surface I found here or no surface. And where that collision occurred. So how we implement this reticle behavior is on every frame, we cast out a ray from the device and see if we get a hit. And if it hits the surface, we change the reticle to provide some visual feedback. And in this use case, we say, hey, we found a surface, tap again to place a model. So I'm going to show off some example code of implementing this reticle. And I don't want to get too deep into this at all for several reasons. One, it's not in Canary yet, and there will be better resources to come, better than me talking about it, like a code lab and other documentation. So most of this code is the same as if you're doing a VR experience with WebXR. We can request a device from Navigator XR, and we also need to create an XR presentation context from a Canvas element. So this is very similar to getting a WebGL context from Canvas, and this is the canvas that is visible to the user and injected into the DOM. As a big caveat, there's absolutely no error handling here that should be done. So then we also request a session on that XR device, passing in our XR presentation context. So this request session is the part that's not fully spec'd out for augmented reality yet. Ideally, in the future, this is where you would request specific augmented reality features, so you can kind of react to different environments, different platforms can support different features. And right now, once this lands, if you enable the augmented reality flag, everything's always AR. The camera feed will always be rendering, and the underlying AR platform will always be running. So it has battery implications and as well as privacy implications for using these features. So that'll change very soon. So this is a lot of code right here, I know. So there's a lot of boilerplate. This will all be abstracted away behind libraries. But really quickly, we need to set up another canvas that we write the WebGL commands to. So this gets mirrored over to the XR presentation context that we just injected into the DOM. So this is probably the weirdest part of WebXR. You actually have two canvases, one that you write to that is not in the DOM, and one that displays that content that is in the DOM. So it's very different than other kind of 3D stuff. So things of note here is we create a frame of reference and for our session, and then we start a request animation frame loop using our session's request animation frame. We have to hook into the native device in order to sync everything properly. So similar to, this is, again, we're working with 3D, so this is similar to other kind of WebGL3 JS development where we have a render loop. So in our render loop, we get our device's pose, and that contains like a matrix representing our device's position and orientation, and then we render every frame, our virtual content that matches perfectly with our real world. And then we call this reticle update function. So this reticle is a custom 3JS class. It represents like a disk on the ground that can trace surfaces. So in every frame, we're calling this update function. And again, I'm glossing over all the details right here. But ultimately, we need an origin point and a direction vector representing this line coming out of our device. And we have a variable hits, and that's an array of all the hits that we found. And it's very easy to not find any hits if we're in low lighting or there's no kind of discernible features on the surfaces we're looking at. So if we found a hit, great. It will contain a 3D position and orientation, and we'll use that to position our reticle. And if we don't have a hit, maybe we can fade out our reticle or hide it completely. So no worries if that didn't completely make sense. The WebXR spec can be difficult to use, especially if you're unfamiliar with 3D on the web. And I mostly just wanted to share the high-level concepts and just to show what it looks like. And there most definitely will be libraries that will abstract this away. So what's next in the near future? So like I said, sometimes in the next few weeks, AR will land in Canary behind a flag. And with this flag, like I said, augmented reality will always be on. So, and we want this to be more fine-tuned. So the request session API will have to be fleshed out. And right now, we only support hit tests, that abstraction over the underlying surface or mesh data that the AR platform provides. But in the future, we would like to expose things like point clouds, surfaces, mesh, light estimation, as well as things like anchors, which are abstract 3D points that you can place around the world that over time, as the system understands the scene better, that will update and become more accurate. And right now we're hand coding all this XR stuff. There's a lot of rough edges. The spec is still under development, and we're making tools internally as needed. So libraries like Three.js currently support some XR use cases, and in the future we imagine this would also support AR. And if you're familiar with Mozilla's A-Frame WebVR library, after we made our prototype browsers, I think someone like a week later made an AR component that worked great. So that community is very proactive. So we imagine like all these libraries will support creating AR for a better experience rather than using the API directly. So what I'm talking about right now is mostly mobile AR. And this provides a lot of immediate solutions for things like shopping, education, and entertainment. And this is only the beginning, as the future gets much more interesting and weird. So that's the immediate future, the next few months or year. What about the next 5 years? A little further out, we can imagine computer vision and machine learning being used with augmented reality. Mozilla has been working on their own prototype browsers using AR. And they've been doing some research with computer vision within WebXR. And something that's been talked about a lot in the AR industry is this concept of the AR cloud or cloud anchors, which lets multiple users share their virtual world. So this feature is currently an AR course and works for iOS and Android, but this will be critical to have also on the web. Unclear if it'll be different services or part of the native API, no idea. But this is necessary and critical for multi-user immersive content. And hardware is making a lot of progress. So with the latest generation of VR headsets, these all-in-one headsets, 6DoF tracking for VR is much more accessible now. Rather than needing a whole room setup where you're installing I forget what they're called, like lasers to track your movement, and also like an expensive gaming computer, essentially. So we're getting closer to these like smaller, accessible, rather affordable comparatively headsets that people can use. And currently there are AR headsets like Microsoft HoloLens, Meta 2, Google Glass for Enterprise, and soon the Magic Leap. So these AR headsets are already out. They're all quite expensive. And they're specialized hardware. And in this head-mounted display AR world, like those will be supporting browsers. So this specification also has to work for mobile, but as well as these head-mounted displays. And in these head-mounted displays, we'll have new input paradigms. We won't have physical screens to interact with. The HoloLens has like a pretty good support for like hand gestures to interact with content, as well as voice commands. So we seem to be trending towards that, like a limited physical interface and using more computer vision, machine learning to interact with this virtual environment. So further out in the future, and this is looking at trends, making informed guesses, but at the end of the day, they're still guesses. We have no idea. So head-mounted displays will evolve into, hip glasses with, these AR capabilities, years out. And, once we have these socially acceptable headsets and we can anchor content in the real world, we can reframe what immersive computing will look like in the future. Contextualized information that is highly scalable, discovered serendipitously, instantly accessible, secure, and interoperable across devices. And that sounds a lot like the web. So imagine walking down the street as contextually relevant content is appearing. We're securely executing arbitrary content, which, that's what the web is for. And in this future, our immersive user agents have even more responsibility. It's necessary for users to be able to control and filter that content, especially since content can be obstructing our vision when we're crossing the street, for example. So, it's pretty important. We need to get that right. So these are just some trends based off of technology, but in the future, society will drive immersive computing more so than technological possibilities. Cultures will define their relationships with immersive technology based off of their social intimacy and privacy values. Usage will be influenced by states' legislation or indifference on data ownership, net neutrality, and corporate regulations. A society's economic equality will determine access to these immersive technologies, and therefore its creators, directions, and applications. And the outcome of each group's socio-political decisions will define their relationship with this technology. We can have some societies that are comfortable with ubiquitous, always on, always recording, head-mounted displays in public spaces, and others could just use it in an as-needed basis, like for education or training. So our culture, laws, and technology are all intertwined, and it's important to consider all of this within the context of society. So there are a lot of unknowns. Some are exciting, some are terrifying, and within these unknowns, that's where we must exert our influence. We must design a future that puts human first, not existing power structures. And it's important to listen to tech critics, sci-fi writers, and groups underrepresented in tech, and ask, how can this be used for evil? This ubiquitous, always-on technology has massive privacy implications, and this trend of cloud computing could contribute to some surveillance state. And so maybe we can steer this more towards on-device computing. The combination of augmented reality, computer vision, and machine learning is already being shopped around to police departments around the world for facial recognition purposes. This could threaten civil liberties until or unless our laws catch up with technology. Unchecked capitalism could result in hyper-consumerism unless we have the ability to control this content. And if this technology isn't accessible to all, then we can further increase the digital divide, separating between those who have and have not. So we must constantly be vigilant as technologists and steer this towards good. Patricia had a great talk yesterday on ethics that all that applies here as well. But enough about the terrifying parts. There's also a lot to be excited about. So we are in uncharted lands. We're learning about this medium as it's being created and as we go. So Apple, Microsoft, Google have all published these UX guidelines, and they're just scratching the surface of what's possible now and in the future. You could invent the next gesture that is as ubiquitous as scrolling or clicking and interacting with these virtual objects. And when we're talking about the web, we have access to hundreds of thousands of NPM packages that we can use and mix and match in our projects. And there are no immersive technology libraries currently. So you could invent the next jQuery or Lodash or React that is used in these environments. And I was originally going to say there are no killer apps for VR or AR, but I played Beat Saber like a couple weeks ago, and it's awesome. Beat Saber aside, as an industry, we're still exploring what is the application that gets people to jump into virtual reality and augmented reality to get over that initial friction. So since immersive computing is this multidisciplinary field, I think we're going to see a lot of new collaborations coming out. So like a fashion designer and a historian, or a machine learning expert and a social worker, or in this case, an audio engineer and a Jedi. So it's a super exciting time to start these new collaborations as engineers and designers. Matt Miesniks has a great article on AR-first applications, and something that stuck with me here is with new mediums, we mostly just port the previous or older mediums into it. So like when mobile was a new thing, we mostly just had tiny websites on our phones. It wasn't until we started leveraging things like location and constant access or always connected devices that we truly leveraged the platform with things like Twitter and Lyft. And same with augmented reality. A lot of augmented reality applications are kind of just putting 2D content around the world. And a lot of it's like, well, this could have just been a website. This would have been easier. So we're still discovering what are the applications that truly leverage this new medium. And it's still important to play around and explore and have fun with this medium. So before I'm done, I'll leave you with a few links. The Immersive Web Community Group is on GitHub. You can contribute and follow along with the WebXR spec there. And Mozilla's A-Frame is a great technology that uses web components to create VR and augmented reality scenes. You don't have to be familiar with 3D or WebGL or any of that stuff. And the Immersive Web Weekly is a newsletter I started a few weeks ago that's summarizing all that's happening in this fast-moving space. So be on the lookout for AR landing in Chrome Canary very soon, and hope you all explore the future. Thanks.